All right, so today we're just looking at solving quadratics again, but we're going to start with things that need to be simplified first before you can actually solve them. So if we take a look at your first example, number 1, we have 9x squared plus 34x equal to 8. All right, now, remember, quadratics or polynomials in general, if it's a polynomial, we're looking at things where your exponents are 2 or greater. So if you know you have something that has exponents larger that are 2 or larger, all right, you're going to have the equation set to 0 before you can start solving it. All right, right now it's not set to 0. Right now it's set to 8. I need for this to become a 0. So I'm going to subtract 8 from both sides of the equation. That way 8 minus 8 makes 0. Those cancel out. And over here, since the 8 doesn't have a variable, you can't subtract it from any of these because these have variables. So you're going to be left with 9x squared plus 34x minus 8. Once you have everything on the same side of the equation and it's set to 0, now we can decide how we're going to solve this. So can I factor out something? 9, 34, 8. No, there's nothing in common, so there's nothing I can factor out. Let's see if we can factor this into 2 binomials. So if I multiply 9 times 8, I get 72. So now I'm going to need 2 numbers that multiply to make 72, and they have to subtract to make 34. The fact that they have to subtract to make 34 means they have to be 34 apart. So let's start. If I have 1 and 35, those are 34 apart. If I multiply those will give me 72. So let's start increasing them. How about 2 and 36? All right, 2 times 36 definitely gives me 72. And if I subtract, I do get 34. So there's the 2 numbers I want. So 2 and 36. And I need to get a positive 34. So that's a positive 36 and a negative 2. So I get 9x squared minus 2x plus 36x minus 8. This gives me x times 9x minus 2. Plus, these can be divided by 4, leaving me with 9x minus 2. So I get x plus 4 and 9x minus 2. And remember, this is all equal to 0. And so now I can solve this by setting each one of these to 0. So x plus 4 equals 0, x equals negative 4. Take 9x minus 2, do the same thing. 9x minus 2 equals 0. That gives me 9x equals positive 2 because you add the 2 to the other side. Divide by 9 and I get x equals 2/9. So here are my 2 solutions to this equation. X equals negative 4 and x equals 2/9. Let's go down and take a look at number 2. All right, for number 2, we start with 25x squared. Then we get plus x times 7x minus 4 equal to 7x squared. All right. So we're going to need to simplify everything first. I don't care what kind of equation you're working with. Your first step in equations, if you have parentheses, you got to do the distribution, and then we got to start combining like terms. So let's do that. Do my distribution first. So I already have 25x squared. I'm going to multiply x times this. That makes 7x squared. X times this makes negative 4x. Yeah, so squared. All equal to 7x squared. So I see I have a polynomial. I got exponents of, wait a minute, did that start out right? Yeah. All right, so I can start combining all my like terms now. Now I need to get everything on one side. Because remember, if we have a polynomial, then where our exponents are 2 or higher, we need to get everything on one side, set the equation to 0. So I'm going to take this guy, I'm going to bring it over here by subtracting. So minus 7x squared, and over here, minus 7x squared. I can see that my 7x squareds are going to cancel each other out here. So since those cancel each other out, the only thing I'm left with is 25x squared minus 4x equal to 0. Now from here, let's see if we can factor something. So both of these can be divided by an x, so let's take out the x. That makes x, and then times 25x minus 4 equal to 0. From there, now I can just set each one of these equal to 0 to solve. This one gives me x equals 0. This one's going to give me x equal to 4/25. And so there are the two solutions to this equation. Go to number 3. So number 3, I have 4x cubed plus 7x squared minus 30x equal to 5x squared. All right, again, starting the same way. I can see I'm going to have a polynomial here, and I don't want it set to 5x squared. I want it set to 0. So let's go ahead and subtract this over to the other side. So minus 5x squared. Now, I can only subtract an x squared from another x squared. So this is going to be subtracted from this guy here, minus 5x squared. I'm going to be left with 4x cubed, 7 minus 5, I get positive 2x squared, minus 30x equal to 0. Now that it's equal to 0, now we can begin solving. So is there something I can factor out of everything? Well, I can take out an x, and I can also take out a 2. So we're going to take out 2x. That'll leave me with 2x squared plus x minus 15 equal to 0. Now I need to see if I can factor this guy down. So multiply 2 times 15, that makes 30. Now I need two numbers that when I multiply make 30. When I subtract them, I'm going to get a positive 1. So I'm thinking 6 and 5. Has to make a positive 1, so that's a positive 6 and a negative 5. Let's put the negative number first. So I'm going to get 2x squared minus 5x plus 6x minus 15. Factor this part, I can take out the x, leaving me with 2x minus 5. Over here, I can take out a 3, so plus 3, and then I get 2x minus 5. So I'm going to get as my binomials, I'm going to get x plus 3, and then 2x minus 5. And don't forget the 2x we took out in the beginning. That guy is still here in the front. And all of this is still equal to 0. All right, so now that this has been factored, now I can apply the zero product property. So let's set each one of these equal to 0. If I set this equal to 0, 2x equals 0, I get x equal to 0. If I take x plus 3, set it equal to 0, I get x equals negative 3. And then I set 2x minus 5 equal to 0. Add the 5 to the other side, I get 2x equal to 5. Divide by 2, I get x equal to 5 over 2. Let's see, that was number 4. Moving on to number 4. So number 4, we have 5 times x squared plus 1 equal to 2x squared plus 4 times x plus 2. All right. So again, we need to simplify everything first by getting rid of our parentheses. So I have distribution to do here, and I'm going to have some distribution to do over here. So here I'm going to get 5x squared plus 5 equal to 2x squared. And now 4 times x, I get plus 4x. 4 times 3, I get plus 12. After that, let's go ahead and get everything on the same side. It doesn't matter which side you want to put everything on. You could put everything on this side. You could put everything on this side. It's up to you. I'm just going to put everything here on the left side. So, well, actually, no, I'm going to put it on the right side this time because that way I only have to cancel out these two. So if I cancel out my 5, that's minus 5. Those cancel. The 5 is going to get subtracted from this one here, minus 5. And then my 5x squared, cancel that guy out by doing minus 5x squared. So that cancels. And my 5x squared is going to get subtracted from this one here. Because remember, an x squared can only be subtracted from another x squared. So minus 5x squared. So over here, I'm going to get 0. This minus this makes negative 3x squared plus 4x, and that's going to give me plus 7. All right, so now that it's set equal to 0, now we can be solving. I don't have a common factor to take out, but remember, whenever we're factoring our trinomials, we don't want to leave a negative in the front. So the first thing I'm going to do is I'm going to take that negative out, making it 3x squared minus 4x minus 7. After that, now we can go ahead and start factoring. So 3 times 7 is going to give me 21. So I need two numbers that multiply to make 21, that when I subtract them make 4, and I'm thinking 7 and 3. So in order to get a negative 4, I'll need a negative 7 with a positive 3. So now that's going to make 3x squared minus 7x plus 3x minus 7. Take out the x, I'm left with 3x minus 7. Here I can't take anything out, so we just take out a 1. So I put plus 1, and I get 3x minus 7. So my binomials are going to come out x plus 1 and 3x minus 7. And we also took out a negative in the beginning, so we'll keep that negative there. I'm going to erase some of this other stuff here. Let's erase this now. And this is equal to 0. You could put equals 0 on the other side if you want. It's the exact same thing. It doesn't make a difference. And so now I just set these equal to 0 and solve. You notice the negative isn't going to affect anything. So don't try to turn this into a solution. You can just ignore that negative. You're going to take x plus 1 equal to 0, so x equals negative 1. 3x minus 7 equals 0. 3x equals 7. So x equals 7/3. And so there are my two solutions. Let's take a look at the last one really quick. If I have x squared over 2x minus 3 equal to 5x over x plus 2. All right, so whenever we have a fraction equal to a fraction, you are always going to cross multiply. So I'll first multiply x squared times this. So that's x squared times x plus 2. And that's going to be equal to this times this. So that's 5x times 2x minus 3. After that, I do my distribution on both sides. So I'm going to get x cubed plus 2x squared equal to, that's going to make 10x squared minus 15x. From here, I got to get everything on the same side. So again, it doesn't matter. Pick the left, pick the right. It's going to work out the same in the end. I'm going to put everything on the right side this time. So I already have an x cubed over here, blah, blah, blah. I need to cancel this guy. When I cancel this one, this will subtract with this one here. So minus 10x squared minus 10x squared. That cancels out. I'm left with x cubed minus 8x squared equal to negative 15x. So now I have to cancel this guy out. So now I'm going to do plus 15x, and over here plus 15x. Now on this side over here, I can't actually add 15x to either of these because the exponents are different. Remember, you can only add variables if the exponents are the same. So I'm just going to get this. I'm going to get x cubed minus 8x squared plus 15x, and all equal to 0. So now from here,